Sorry, I
Hello
think
to the
Bruno, I can't
audience.
hear you.
Yeah, this is Jake speaking from the
I can hear
background.
shaky,
Bruno,
but
yeah, Bruno, your microphone is muted.
Okay, I unmuted. All right. My setting
This was
didn't
an
show me the unmute
unusual
button.
start, but we'll take it from here. Thank you very much,
All
sir.
right.
Please carry on.
I was saying bonjour. Bruno LARVOL here, and this time unmuted, building public. We are sharing with our community, with our customers, what we're doing at LARVOL. All right. And in particular with LARVOL CLIN, our oncology clinical data platform. Today, with Sridhar already ahead of product, we're going to talk about IPD, or more precisely, pseudo IPD. Some of you know what it is, some of you don't. IPD is individual patient data, and pseudo IPD is a reconstruction of IPD. We'll explain how. It's a new feature of LARVOL CLIN. So first, Happy New Year, Happy New Lunar Year. One of the tradition in some part of the world is actually to get a very short haircut. In my case, I shaved my head for the new year. My wife is still getting used to it, but we'll see how long I'll keep it. So Happy New Year, everybody. Build in public is a way for us to share our journey. And today, as we build LARVOL CLIN as the Wikipedia / Bloomberg / AI Palantir-like in cancer data, I have with us Sridhar already, our head of product. Hi, Sridhar. Welcome to the podcast. Oh, a little delay. Sridhar, can you hear us?
thanks, Bruno. Thanks for having me again. Yes, I can hear you. Can you hear me? Or is
Yes,
there a
we
delay?
are on. We are on. All right.
I can
So
hear you fine, Bruno.
let me say a few words on pseudo IPD, and then I'd like you to give a demo for our audience. So once again, LARVOL
Sure.
CLIN is a Wikipedia of all data that we can publicly access and publicly structure using our AI and our technology from cancer clinical trials. We capture about 40,000 Kaplan-Meier curves. These are survival curves, as many of you know. And we also capture, using our AI, the at-risk patients under these survival curves. With that, we use standard biostatistical technology to reconstruct the pseudo-IPD. So pseudo-IPD are essentially a reconstruction at the patient level with the information we have of what's happening to that group of patients in a clinical trial. And then Sridhar and his team have, with the help of Judith Perez and Darko Medin on the biostatistical side, have built a new feature, which is beta, and which now Sridhar is going to demo. So the baton goes back to you, Sridhar.
Sure. Thanks, Bruno. And as you can see, so there is a new tab that is added to CLIN, which is still in beta. A lot of work happening. There are a lot of tweaks and enhancements that we will be planning to do. So we have a KPD or key population tab that is recently added a couple of weeks back. We continue to work on that key population tab. And in addition, we added another new tab that is in a kind of an experimental phase, but that's exciting to see the first draft or more like a POC. So it's a beta. So let me just directly go ahead and jump to the pseudo IPD tab. So we have the regular search feature wherein you can search for the trials using the default filters, or you can go and search for the advanced filter. Let me, for this case, take my favorite one, that is, I'll go for RCC, or the renal cell carcinoma. I just want to give a heads up that some of this is still in progress, so you may see a slight delay. So when I go for renal cell carcinoma and click on show results, we get to see all the trials that belong to renal cell carcinoma. So in this case, probably, if I'm right, maybe about 1,500 trials. I could be wrong, but let me make a guess there. So The tab looks somewhat similar to the Kaplan-Meier plot, where you'll be doing filtering based on any of these conditions. Oh, sorry, it's only 68 trials that have the keep the information right now. Um, so we have 68 trials that are filtered for renal cell carcinoma, and for each trial, as you can see in the dashboard, we have the list of curves. So I can click to expand the curves, and I could see the source and the curve description and the curve dashboard looks exactly similar like the KM tab if you're already familiar with the KM tab. However, the difference here is that in KM tab, I can just click on the curve and it gets drawn or it gets rendered on the screen. But under pseudo-IPD, as you mentioned, Bruno, we are trying to generate one unified pooled curve. And the way we do it is we select the curves that we'd like to include to generate the pool data. Right now, you could select both the experimental and um, the intervention and the control arms. You can select both of them, and once you select this, just to have a good amount of sample data.
Of course, the selection of these curves is essential. Someone
So in
like
this
me,
case, I randomly selected 4 curves from different trials. Yes,
there's a bit of a delay here, but go ahead. I don't want to interrupt.
got it. Sure. So I randomly selected 4 curves from different trials, and I click a button that says Create Pool Curve. Ideally, if you're looking at KM tab, the moment you select these curves, you'll see a KM graph getting rendered on the screen, and you'll see the solid line and the dotted line, the intervention, the control arm, basically. But in this case, I have to click on Create Pool Curve. Again, as I told, this is in beta, so we are experimenting and we are trying to analyze how the curve is getting created. But so far, I would say like it's pretty promising. We definitely need to work on the speed, of course. As I mentioned, like in this case, you can clearly see it's taking a bit of time for the data to be calculated and to be fetched and displayed. So you can see one single curve, which is what we are calling as pooled curve. So that's the reason why we even call this as pooled data, pool Z, which is our internal language. So getting created by taking by combining the data from the 4 curves. So
Maybe
this is
show
the
the
pool
original
curve.
curves as
I
well.
can
Yes.
also click on Show Original Curve. Now, I'm not sure if there is any bug here or some issue, but push to the left. Maybe there is anomaly somewhere.
Oh, we
It
found a
looks a bit
bug.
odd, but let me,
But we
so,
found a bug. It's
let me
very
try to do.
important case. We've
No,
what was the difference between the first time you show it and the second time?
yeah, there seems to be maybe data for one trial that may need to be looked into, but when I
No, but
just
try
unchecked
to
one of the
replicate
curve, and it will
the
go back.
previous situation when you had all of the original curve compressed to the left. Can you try to replicate that?
Um,
Because that was, I think, a
I'm doing
display
that.
bug. So try
So
and this is a spirit of building public, by the way. We want not to hide any problem
okay.
there. Yeah, I want you to show that slide. So in this case, that we found a bug.
So
That's why it's beta.
one of the curve for checkmate 025 is the one that is creating a problem. Yeah.
Okay, but it's a bug. I think there's a bug there, and because of that, it seems that all of the data, the display of the data, is not consistent between the original curves and the pooled curve. You see what I mean? Now, in this case, it is consistent-ish, right? In this
Right.
case, it's
So I
interesting
unchecked that
because
one curve that is
yeah,
creating a problem. Yeah,
The connection created a little delay in this call, unfortunately, but that's okay.
please go
So
ahead, Pranav.
in this case, there's something else interesting happening, is that if you look at the original curve, you got 4 of them, and look at the pool curve, there's one of them in purple, a solid line. What we see is that only one line is above. So that's going to be a good one to QC, because the only way that will be feasible is that the number of patients in the brown curve above the
Mhm.
purple line is essentially 5 times more than the other 3 or 4 times more. If not, the purple curve will be in the middle of all of them, but it's way, way up. So it means, and that we should check that, by the way.
Mm.
It means that, and if that's the case, we found another bug, but I don't think that's the case. I think what's happening is that the reason why 3 of the 4 curves are below the purple curve is that the brown curve has more weight because it has a lot more patients. And on my
Right.
screen, I'm trying to look on the right here with my middle-aged eyes, and I think that's the case. You look 17, right? Although the second curve also has a lot, and the last, no. So that doesn't explain it, right? The brown curve is the last one, and it doesn't have more patients. So,
The brown is the last one.
right?
I think
But
in this case, probably the median. Yeah.
so it's still a mystery, while 3 of the 4 curves are below. So let's take a screenshot and check with our team, trying to understand that case as well. So we're going to be at the end of our call in a second, and we found some together, some questions that we have to answer in order to make sure that there's no bug behind our data, because right now it doesn't look quite right that the purple will be completely to the top of that stack of lines. You follow my thinking?
Yes, Pranav, that's right.
Okay, so I want to thank our audience. We're going to be toward the end of this brief sharing with all of you. This is Building Public, so we're sharing openly with you our working sessions, essentially our demos, and we hope that you learn something interesting. We assume you're interested in cancer data, especially clinical cancer data, and any large-scale biostatistical and AI treatment of clinical cancer data. That's what we're thinking about day after day, and sometime not even the day, but during the night as well. And I would like everybody listening interested to drop us a note, a comment, or request. We'll be happy to give you a demo, perhaps even sign you up for a pilot access to LARVOL CLIN. A free version exists, but it has some limitations, and I don't believe that you can access the pseudo IPD on the basis of the free version. Any final words from you, Sridhar, and then we can close up this session.
Yeah, I mean, obviously we need to identify all these and fix all these bugs, Bruno, before we fully go live. And also there are some exciting new things that will get added. For example, we want to do this pool curve individually, both for the experimental and the controlled arm. So right now it generates only one curve, but the idea is that users will have the ability to generate these pool data individually for both experimental and control to see how it is. So there are a lot of variations that we are currently working. A lot of it is under discussion. Not everything may be feasible, but we have been working on adding some new features to this tab.
That's right. So once we fully stabilize this first aspect, an additional feature we're going to add to our pseudo IPD element is adding a second line. So you'll be able to have a synthetic curve or pool curve, let's say for an experimental simulated arm of a trial, and compare it to a simulated control arm by picking a historical control and merging them into a pooled comparison arm. Obviously, in doing so, important caveat, you lose the power of randomization, and therefore the statistical interpretation needs to be adjusted. This is not at that point a randomized, statistically randomized comparison. So it means something very different. And some purists might say it cannot be used in some use cases. I think they're right. For example, you don't have the ability to go to the FDA at this point, at least, with a synthetic trial, a synthetic comparison of two pooled curve. But who knows? With AI down the road, we'll have to see what happens. On that note, I'd like to thank everybody in the audience again, and we'll see you next week.